Hi everyone, I hope you're doing well at home and taking this opportunity to feel good about contributing to hopefully flattening that exponential growth curve of COVID-19, and hopefully soon enough we'll be back in class together. In the meantime, I've made these videos for you to help you learn the materials, so please stop and start as you need to learn the material. Try everything on your own as you go and really try to take it seriously and do your best, because we all need to work together on this so that you don't miss out on learning anything important in case you want to take calculus next year or continue with math. So we're on 5.3 now. Hopefully you did your summary chart and you've reminded yourself of all the meanings of the parameters and applicable formulas for transformations. So we're going to do this example here. Transform the graph of f of x equals cos x to sketch g of x equals 3 cos 2x minus 1 and state the period, amplitude, and phase shift of each function. Okay, so I'm just going to state the period, amplitude, and phase shift for the transformed one because you should know them already for our basic cos x. My preferred method for this is to do a mapping notation. The textbook uses a different method of just layering on the transformations. That's fine too. If you like, you can look in the textbook to learn that one. But I'm going to do it with a mapping notation. So in order to make a mapping notation, which I've actually already written down here at the bottom, we need to know what the transformations are on g of x. So if we just look at the parameters one by one, first one is a, which is 3. That obviously gives us the amplitude, but it also tells us that there's a vertical stretch by a factor of 2. The 2 directly in front of the x, that's our k value, and that tells us that there is a horizontal translation by a factor of 1/2. The minus 1, that's our c value, and that tells us that there is a vertical translation. I'm not doing shift because I'm using s for stretch up here, so I'm doing vertical translation 1 unit down. When we apply all of those transformations to a general point xy, we get 1/2 x and 3y minus 1. Make sure you apply the horizontal transformations to the x value only and the vertical transformations to the y value only. So continuing with that mapping notation over here, we need to take our basic table of values for f of x equals cos x, which everyone should have memorized by now. Probably you memorized it in grade 11 math already. So that is our basic table of values for cos x right here. Multiply all the x values by 1/2 and we get these ones. Multiply all the y values by 3 and subtract 1 and we get these ones. And then we can just go ahead and graph or plot those points on this ready-made graph that I have right here. Notice that for my scale, I chose to go by pi over 4 because that is convenient for my x values. And, pi over 4 should be -1. Pi over 2 should be -4. 3 pi over 4 should be -1. And I'm doing 2 cycles just to continue it a little bit here. You weren't asked to do 2 cycles, but I'm doing 2 cycles anyway. And I can just continue that pattern of points to get the second cycle. So I'm going to try and make as smooth a curve as possible. It's a little tricky on this device. Okay, so it looks something like that.